Welcome to Toshiba's Motor Parts video tutorial. In this video series, we will highlight the various parts of an induction motor and the resulting benefits to the end users. Stay tuned for upcoming videos and follow Toshiba International Corporation on Twitter and Instagram. The first thing we see when looking at a motor is its robust enclosure. Most of our low-voltage motor enclosures are made out of cast iron. Cast iron is extremely strong and resistant to oxidation, making it an ideal material for a severe-duty induction motor. On the very top of the enclosure, you will notice an eye bolt. A forged shoulder eye bolt is provided for lifting on 182T frames and larger. Frames N449T has two cast-in lifting provisions. The eye bolt is threaded into a blind hole in the motor frame, which prevents entrance of moisture and contaminants into the motor if the eye bolt is removed. The second detail most people notice are the shiny nameplates. Standard nameplates are 304 grade stainless steel with stamped or raised lettering for lifetime legibility. The nameplate is attached to the motor frame with 4 stainless steel rivets. Toshiba nameplate information includes standard NEMA data, motor weight, lubrication type, bearing sizes, inverter duty capability, and hazardous location capabilities. The conduit box is where the input leads are connected to the incoming line. Most of our conduit boxes are oversized in order to make installation and startup an easier task. We have also standardized all cast iron boxes throughout our entire line of low voltage motors. Inside of the conduit box, you will find the connection diagrams, applicable safety warnings, and a location for your ground wire. All motor frames 140 through 5810 have CSA clamp type grounding lugs in the conduit boxes. All EQP Global 840 and 841 motors are provided with a copper UL approved grounding lug in the conduit box. The lead separator protects the leads from abrasion at the exit point of the frame and offers ingress protection against dirt and moisture. Standard horizontally mounted, totally enclosed, fan-cooled, and open motors are provided with drain holes. All drain options are provided at the lowest point on the motor frame. Drains and breathers help prevent condensation buildup within the motor and prevent the ingress of contaminants. Stainless steel T-drains are standard in Global 840 and 841 motor frame sizes 140 through 360. Bronze drains and breathers are standard in 840 and 841 motor frame sizes 400 and larger. Additional drain provisions are provided in each bearing bracket for vertical mounting on frames 140 to 360. A plug can be used in place of a T-drain or drain and breather to give the motor an IP65 or IP66 rating. Space heaters are recommended for this option. The shaft is a crucial mechanical component of the motor. It is used for transmitting torque and rotation from the rotor to the driven equipment. Shafts are made of different materials depending on the type of motor and application. The most common material is high-strength steel. The shaft is machined to very small tolerances to ensure precise dimensions and a perfect fit. The shaft key is a rectangular bar that sits in the keyway and holds the coupling and the fan in place. External cooling fans are non-sparking, corrosion-resistant, conductive glass-reinforced nylon on frames up to 405. Frames 444 and larger have either nylon or aluminum fans. Glass-reinforced nylon fans provide better durability and is more abrasion-resistant than a typical standard plastic fan. The snap ring holds the fan in place and keeps it from sliding off the shaft. The fan cover serves two purposes. It protects the fan from damage, and it guides the air through the enclosure's fins to help cool the motor. The fan covers are made of pressed steel in our SD line and cast iron in our 840 and 841 line of products. The mechanical labyrinth seals provide an IP56 degree of protection. They provide superior protection against ingress of contaminants and moisture. Labyrinth seals are provided on both ends as standard on all 841 motors and 840 motors 400 frame and larger. The V-ring is a neoprene shaft seal. It has an IP55 rating. The V-ring is standard on all global SD motors and 840 motors up to 360 frames. The umbrella seal is standard on both ends of the cooling tower motor, as well as the 840 motors frames 320 and 360. It has an IP56 degree of protection. It offers additional protection against moisture ingress in vertical and horizontal application. Going further inside the motor, the very first component past the seal is the bearing. We use oversized bearings, 300 series on the drive end and the opposite drive end. This allows for higher load rating capabilities, resulting in longer bearing life. This is also better suited for overhung loads or belt-driven application. We size all of our bearings to provide a minimum of 40,000 hours for belted applications and 150,000 hours for direct couple applications. A lubrication sticker is attached to motors with regreasable bearings in order to facilitate proper motor maintenance. Stickers are placed on 841 motors up to frame 445T and on 840 motors frames 280 through 445T. A stainless steel grease plate is used on 841 and 840 motor frames 449 and larger, and on SD motor frames 5010 and larger. Another detail you may notice are the grease nipple and the grease relief plug. These parts are included in all motors with regreasable bearings. The grease nipple comes complete with a cap that prevents contaminants from entering the bearing housing through the open relief port. 841 motors have an automatic low-pressure grease relief fitting. The bearing felt creates a grease seal on the inner and outer bearing cap, preventing grease from entering the motor. It's standard on all frames 440 and larger. It's also standard for oil mist options on every frame. Bearing lock nuts are standard on motor frames 440 and larger and on all vertical P-flange motors. They help minimize shaft end play. A wavy washer, also called a spring washer, is located on the non-drive end that limits the end play while allowing for thermal expansion of the shaft. Large cross-sectional slot area permits increased slot fill and lower resistance. Thinner laminations, we use 26 gauge. It allows for lower eddy current losses. Low-loss electrical grade silicon core steel is used. C5 inner lamination insulation is capable of withstanding 1,000-degree Fahrenheit burnout with a temperature-controlled oven. This prevents the chance of core loss during the burnout process and allows for multiple rewinds. There are two main types of coils, random and form wound. The great majority of our low voltage motors, severe duty 840 and 841, are made with random wound coils, also known as mush wound. The great majority of our medium voltage motors are made with form wound coils. High-purity copper windings allow for lower resistance and lower losses. They are standard in 2300 volts and above, and also available in some larger low-voltage designs. They provide excellent environmental endurance for longer life. Form winding is always provided with a VPI-type insulation system. Our standard insulation is an F-class insulation system with H-class components. The windings are dipped in a severe-duty H-class polyester varnish resin. This superior insulation system provides high thermal capability, high ambient temperature operation, a high dielectrical and mechanical strength, all of which makes our standard insulation system inverter duty per NEMA MG1. Space heaters are strip-type silicon heaters mounted at the bottom of the frame under the coils to prevent condensation in the motor during times that the motor is not energized. Shaft grounding provisions help eliminate shaft currents induced into the motor through upstream controllers, such as adjustable speed drives. These currents lead to premature failure of the bearings, commonly referred to as fluting. Shaft grounding rings are available on motor frames 140 to 505. In addition, the opposite drive end bearing should be insulated on motor frames 440 and larger. Shaft grounding brushes are available on frames 140 to 5800. When a shaft grounding system is requested, our preferred device is a shaft grounding brush. A total of 3 thermistors are embedded in the windings, 1 per phase. These temperature-sensitive devices have a resistance that increases with increasing temperature. A separate remote mount relay is required for the thermistors to trip. We can provide the relay as an option. Our standard offering of thermostats is a normally closed, bimetallic, temperature-actuated element embedded in the stator winding or laced onto the winding end turns when provided as a stock modification. This device is provided as standard on all explosion-proof motors. A temperature detector with a known temperature resistance characteristic is installed in the stator slots. The standard is 2 per phase, and the leads are wired to terminal strips in a cast-iron auxiliary conduit box. The standard offering is 100 ohm platinum. Copper and nickel are also available upon request. As an option, we also offer bearing RTDs. These are the same temperature detectors as Stator RTDs, but located in both bearings. Our standard offering is 1 RTD per bearing,